9.3 circles will be the first conic section we talk about. And the general equation for this, which is on your formula sheet, is this. So I'll start with that. It is x minus h squared plus y minus k squared equals r squared. So whenever you do a conic section problem, you kind of got to have that formula handy. And this formula, the center of the circle is at HK. That's what those mean. And yes, that's a translation. It means shifting. H means shifting right or left. K means shifting up or down, just like you're used to. And the radius, R, stands for the radius length for the circle. Radius is R. Okay, so and just a quick little picture, if the circle is centered, if the center is the origin 0 0, like this, here's the center at 0 0, so h and k are both 0 in that case, and you drew, just to make it simple, let's say this is the radius R and here's your circle. Then what this equation tells you is that any point on the circle xy, you can get the coordinates of any point around the circle by using this equation. So xy is a point on the circle, hk is the center, but in this case they're both 0, and r is the radius length. And so the reason this works is, if just like we're used to doing in trig, if we make a right triangle, this is the x distance and this right here is the y distance, then you can see x squared plus y squared equals r squared when it's centered at 0 0. Centered at 0 0. Okay, so it's just a squared plus b squared equals c squared. If you were to plug in 0 and 0, you would get x squared plus y squared equals r squared. Okay, so if we move the center, for example, to the right 2 and up 3, then h would be 2 and k would be 3, and so in order to still use this formula, it still is Pythagorean theorem. You basically have to subtract 2 and subtract 3 to kind of bring it back to the center. That's the gist of why h and k work the way they do. So let's try some examples. One of the test objectives for our last unit test would be to write the equation, I'm just abbreviating, equation given the center and radius. Center and radius. So the first one, if I tell you the center of our circle is at 3, -2, and the radius length is 3. So, and I want you to tell me what the equation is. You would just think of this general form, and you would say it's always the opposite. So it'd be x, we just go straight to the equation, x minus 3 squared, using this general form here, plus y minus the y coordinate of the center, y negative, which is -2, equals r squared. And you want to put it in parentheses just in case. So, but we wouldn't leave it in that form. So our final answer is x minus 3 squared plus y plus 2 squared equals 9. And that's the equation of a circle centered at 3, -2. These are both going to be opposites. Center at 3, -2. Why are they both opposites? Because it says subtract up here. Equals r squared. So let's try another one. If I tell you the center is at -4 0 and the radius of a circle is 1, and I asked what's the equation of the circle, then you would say, you would use this form, you would say x minus -4, the x coordinate of the center, squared, plus y minus the y coordinate squared equals r squared, 1 squared. So the final answer in the best form is x plus 4 squared plus, we don't need anything here, just plus y squared equals 1. So that's the easiest they could get when you're given the center and the radius. And probably just as easy is this objective here, is to find the center and radius. We're going to go the other way. Find the center and the radius, length. So I would give you this equation, x minus 3 squared plus y minus 2 squared equals 1. So you would tell me the center is at, good, 3, 2, and the radius length equals whatever the square root of this is, which happens to be 1, yes. So okay, now our last two examples are going to be more involved because we're not going to be given the equation in this nice form that already matches up with the standard form for a circle. We're going to be given it in a different form, and we have to make it look like this. And the way we do it is called completing the square. And we did cover it in semester 1, but we'll review it. And it's what the quadratic formula is based on, is completing the square. So let's say, now let's up the ante here. Well, I still want to find the center and radius. So the objective is still to find the center and the radius. But it's going to look something like this. So I'll say example 3. X squared plus y squared minus 10x minus 6y plus 18 equals 0. So in order to do this, I want something squared. I want the x terms together squared. I want the y terms together squared. And I don't want any constants here. I want it on the other side. So I'm going to write must complete the square. And I'll list the steps on the right as I do them on the left. Must complete the square. So the first step is number 1 is to do grouping. So in other words, put the x squared minus 10x next to each other, leave a little space, and then put the y squared minus 6y together equals, and then move the constant to the other side like that. So that's just grouping the terms that I want together. I didn't do anything else. I just moved things around. So grouping was first. Now I'm going to actually complete the square. So I like to put this here just to show that I'm adding. You're always going to add something. You'll complete the square here and here. And whatever you add in those boxes has to go on the other side as well. So this is... So you complete the square, and that's the way you do it is you take half the middle coefficient and square it. That's the magic number you need to make these factorable, and they will factor as a perfect square, and you'll know that they do because of the number that you pick. So half of negative 10, this is the middle coefficient, half of negative 10 is, and square it. Square negative 5? 25. So it's always going to be a positive number. The magic number is 25, and now I'll be able to factor that. So I have to do the same thing on each side. So let's do the same thing for here. Half of negative 6 is negative 3, square it. It'll always be positive. Positive 9. So you have to do the same thing on each side of the equation to keep it balanced. So now we'll factor this trinomial as a perfect square. So that's the last step, is factor as a perfect, it's called a perfect square trinomial, because a trinomial, there's 3 terms, it's a trinomial, and when you factor it, it'll be a perfect square. So you could, if you want to go back, you could do a diamond problem. What multiplies to 25 and adds to negative 10? So what, I'm just looking at these 3 terms, I'm going to factor it. What multiplies to 25 and adds to negative 10? They will always magically be the same number, always. Because you made it 25 as a perfect square, so these are always going to be the same, and the sign will always be the same as this middle number. So I already know it's x minus 5 times x minus 5. So it's x minus 5 quantity squared. It's a perfect square. And so here, I don't even have to do it. You can go back to diamond, but you want to get faster at things. So what's the answer? Y, yeah, y minus 3 squared. It's basically, this number is half of the middle coefficient. And it would work out. So if you add these numbers together, negative 18 and 25 and 9, you'll get 16. And now look at, it's in the right form. So what's the center? 5, 3, and the radius is 4, the square root of 16. Now it doesn't, you might get a radical, it doesn't have to be a perfect square over here. It might be like, if this were 15, the radius would be the square root of 15, and you would leave it like that. So let's do one more example of this exact thing, and you're going to find with all the conic sections, to get them in the right form, you keep completing the square. And that's why it's so important. So x squared plus, our last example for the day, x squared plus y squared minus 6x plus 8y minus 24 equals 0. So we're going to do steps 1, 2, and 3. 1 is grouping, 2 is complete the square, 3 is factor. So grouping, complete the square, factor. Okay, so grouping. X squared minus 6x go together, and y squared and 8y go together, and then minus 24, you'd add 24 to each side, and it goes like that. So now we're going to complete the square, So what do we add in this box? Good. What do we add in this box? Yes. So therefore, we must do the same thing over here. And now we grouped, we completed the square, we're going to factor. So what is this factor to as a perfect square? X minus 3 quantity squared. And what is this factor to? Y plus 4 quantity squared equals, adding these up, you get which, and it doesn't have to be a perfect square over here, just, so the center is at 3, negative 4. It's always the opposite. Radius is 7. Yes. Very good.